At 1:42 in the afternoon, the sky disappeared. Not slowly. Not gradually. In minutes, the sun was gone. Noon became midnight, and the sound that followed was heard 2,000 kilometers away. 800 people did not survive that day. But 20,000 did, because a small group of scientists, armed with instruments, data, and the courage to warn a nation without absolute certainty, looked at a sleeping mountain and understood, before anyone else, what it was about to do. This is the story of Mount Pinatubo. Of the largest volcanic eruption of the 20th century. Of the 9 hours that reshaped a landscape, cooled the entire planet, and forever changed how humanity listens to the Earth. And of the question that remains quiet, persistent, unanswered, in the blue waters of a caldera lake where a mountain summit used to be. There are places on this Earth that seem, at first glance, like paradise. Lush green slopes, thick forest, villages where smoke rises gently from morning fires, and children walk to school along paths worn soft by generations. Luzon Island in the Philippines was such a place, and at its heart, quiet, overgrown, almost forgotten, stood a mountain, Mount Pinatubo. For most people who lived in its shadow, it was simply the mountain, a presence, a backdrop to their lives, something permanent, something reassuring in the way that only ancient things can be. The Edda people had lived on its slopes for centuries. They knew its forests, its streams, its silences. They had built their world there, high above the lowland towns. To them, the mountain was not dangerous. It was home. But mountains have their own memory, far longer, far deeper than ours. The last time Pinatubo had truly awakened was around the year 1,500, 5 centuries before. Long enough for every trace of its fury to be swallowed by jungle. Long enough for the world to forget entirely what it was capable of. By 1991, no living person had ever seen it angry. No one knew what was coming. And yet, the Earth knew. Deep beneath those green slopes, in the slow and pressured darkness miles below the surface, something had been stirring for a very long time. It would not stay silent much longer. It began with something small. In the early months of 1991, the people living near Mount Pinatubo started to notice things, subtle things, the kind of things that are easy to dismiss when life is busy and the sky is still blue. A faint smell of sulfur on the morning air, a spring that had always run cold, now running warm, cracks appearing in the dry earth near the mountain's base, thin, quiet lines as if the ground itself were trying to breathe. For most, these were curiosities, conversation pieces over rice and coffee. Not warnings. Not yet. But on the 2nd of April, 1991, the mountain spoke for the first time in a language that could no longer be ignored. A series of small explosions opened along the northern slope of Pinatubo. Steam and ash burst from vents that had never been there before. The sound carried across the valley like distant thunder. Except the sky was clear, the earth had cleared its throat. What followed was a mobilization of science. The Philippine Institute of Volcanology and Seismology, known as PHIVOLCS, moved quickly. Seismographs were installed around the mountain's base. Scientists began monitoring the tremors that rippled through the rock day and night, invisible to the human eye but legible to instruments. And what those instruments read was deeply unsettling. The earthquakes were not random. They were moving. Shallow at first, then deeper, then shallow again. A restless, rhythmic pattern that volcanologists recognized immediately. Magma was on the move. Somewhere beneath the mountain, a vast body of molten rock, superheated, gas-rich, under tremendous pressure, was pushing upward, slowly, relentlessly, like water rising behind a dam that has not yet broken. The question was no longer if, the question was when and how large. It was at this point that the United States Geological Survey joined the effort. A team of American volcanologists arrived at Clark Air Base, just 15 miles from the mountain's summit. Among them was Dr. Chris Newhall, a scientist who had spent his career studying volcanic disasters around the world. What he and his colleagues found when they began studying Pinatubo's history gave them pause. Beneath the jungle and the soil, They discovered the evidence of previous eruptions, thick deposits of ancient ash, layers of hardened pyroclastic material, buried deep but unmistakable. The geological record told a story of a volcano that, when it erupted, did not do so quietly. Pinatubo, they realized, was not an ordinary mountain, it was a caldera system, a volcano of extraordinary scale, one capable, in the right conditions, of producing an eruption not measured in local terms but in global ones. They estimated that the previous major eruption, 5 centuries prior, had been many times larger than anything seen in the modern era. Now, with magma rising and earthquakes multiplying beneath their feet, they had to consider the unthinkable. Could it happen again? Around the mountain, life continued, but uneasily. At Clark Air Base, American military personnel went about their routines, watching the mountain from a distance with a mix of curiosity and quiet concern. The base was home to thousands of men, women, and children. In the lowland towns, San Fernando, Angeles City, the provincial roads connecting village to village, ordinary Filipinos watched the news, listened to their radios, and waited. And on the high slopes, the Edda communities watched too. Elders spoke of old stories, of times when the mountain had rumbled before, when the animals had gone silent, when the forest had smelled of something wrong. Some began to pack what they could carry. Others stayed, as people always do when leaving means abandoning everything you have ever known. By the middle of May, the seismic data was becoming alarming. The number of earthquakes recorded beneath the mountain had climbed into the hundreds per day. The ground deformation, the swelling of the mountain's surface as magma pushed upward, was measurable and accelerating. Sulfur dioxide emissions, a key indicator of fresh magma reaching the surface, had spiked dramatically. The scientists held their maps and their printouts and looked at one another across the table. They had seen enough. On the 7th of June, 1991, FIVOLCS raised the alert level to 5, the highest possible, and issued the formal warning that an eruption was not merely possible. It was imminent. Evacuation. Orders went out for a radius of 20 kilometers around the summit. More than 60,000 people were told to leave their homes. And still, the mountain waited. As if it were choosing its moment. As if it knew that the world was watching. There is a particular kind of silence that falls over a place when people begin to leave. It is not the silence of peace. It is the silence of absence, of doors left unlocked, of animals wandering without purpose, of dust settling on tables that were set just days before for family meals. In the villages surrounding Mount Pinatubo, that silence arrived in waves throughout the final days of May and the first days of June. 1991. Families loaded what they could onto trucks, jeepneys, and carbos, the sturdy water buffalo that had worked these fields for generations, mattresses tied with rope, photographs wrapped in cloth, sacks of rice because wherever you go you still need to eat. Children carried their school bags, unsure if they were going on a trip or leaving forever. Most of them did not know the answer. Neither did their parents. The evacuation of the slopes of Pinatubo was, in many ways, a miracle of human coordination. FIVOLCS had drawn concentric rings around the mountain, 10 kilometers, 20 kilometers, 30, each one representing a different level of danger and urgency. Within the innermost ring, the danger was considered extreme. These areas had to be cleared immediately, but convincing people to leave was not simply a matter of issuing an order. For the Edda communities on the upper slopes, the challenge was profound. These were people who had never lived anywhere else. Their identity, their spirituality, their entire way of being was woven into that mountain. To leave was not merely inconvenient, it was, in a deep sense, a kind of exile. Many elders refused. At first, some said they would rather die on their mountain than live as strangers in the lowlands. It took days of careful, respectful conversation by local officials, by community leaders, by neighbors and relatives before the last families could be persuaded to descend. Even then, many looked back as they walked away. At Clark Air Base, the decisions being made were of a different character, but no less difficult. The base was a major American military installation, home to thousands of Air Force personnel and their families. It sat only 15 miles from the summit of Pinatubo, close enough that the ash clouds were already visible from the flight line uncertain. Mornings. The base commander faced a dilemma that had no clean solution. If the volcano erupted as scientists feared, a massive, catastrophic eruption, the base could be destroyed. The lives of thousands of people could be at risk. But evacuating a major military installation is not a simple matter. Equipment worth billions of dollars, aircraft, infrastructure, strategic assets that could not simply be driven away on a truck. And there was always the possibility, the nagging, soldier's instinct possibility that the scientists were wrong, that the mountain would rumble and settle, that the evacuation would have been unnecessary, that the disruption would have been enormous, and the danger nothing but a false alarm. Volcanologists understand this tension well. Predicting an eruption is not like predicting the weather. There is no certainty. There is only probability, evidence, and the weight of professional judgment. Dr. Newhall and his colleagues knew that if they cried Wolf and were wrong, future warnings might not be heeded. The credibility of volcanic science, and with it, the safety of millions depended on being right. They looked at their data again, and again, and they stood by what it told them. The decision was made to begin evacuating Clark. Over several days, aircraft were flown out. Families were transported to Manila and beyond. The base, once humming with the noise of jets and daily military life, grew quieter with each passing hour. It was an extraordinary sight, a superpower's military installation, emptied out not by an enemy, but by a mountain. Nature, it turns out, does not negotiate. Meanwhile, in the scientific monitoring stations ringing the volcano, the data continued to speak. The harmonic tremors, long, sustained vibrations in the rock that indicate the movement of fluid, magma through underground channels, were intensifying. On the 7th of June, a new lava dome was observed pushing through the surface near the summit. This was a significant development. It meant that magma had reached the surface. The conduit was open. The eruption had, in a technical sense, already begun. But what had emerged so far was only a whisper. The magma rising through Pinatubo's depths was not ordinary lava. It was dacite, thick, viscous, extraordinarily rich in dissolved gases. Unlike the fluid lavas of Hawaii, which flow and spread, dacite traps its gases. It builds pressure. It does not release until it explodes. Imagine shaking a bottle of carbonated water for months, years, decades, and then, very slowly, beginning to open the cap. That was the situation beneath the mountain. The gas had been building since long, before any human instrument was in place to record it. The pressure had been accumulating through the entire history of this new, eruptive cycle. The dome at the surface was a stopper, and the stopper was growing unstable. On the night of the 9th of June, the monitoring teams recorded something that made even the most experienced volcanologists stop and go still. A dramatic escalation in seismic activity, not just in frequency, but in magnitude. The mountain was no longer clearing its throat. It was beginning to speak in full voice. And what it was saying, to those who knew how to listen, was this: I have been patient long enough. There are moments in history that divide time into two parts. Before and after. For the Philippines. For the thousands of families who lived in the shadow of Pinatubo. That dividing line arrived not as a single dramatic instant, but as a sequence of days. Each one darker and louder than the last. It began on the 12th of June, 1991, Philippine Independence Day. A day that, in every other year, was one of celebration, of flags and parades and the particular pride of a nation that had fought long and hard for the right to call itself free. This year, the celebration was muted. Because on that morning, Pinatubo erupted. The first major explosion sent a column of ash and gas roaring upward into the Philippine sky, rising to a height of nearly 20 kilometers above sea level. 20 kilometers. To understand what that means, consider this. The cruising altitude of a commercial aircraft is roughly 10 to 12 kilometers. This column of fire and ash rose twice that high, punching through the troposphere, breaching the lower stratosphere. spreading outward in the shape of an enormous, terrible flower. From the ground, those who remained close enough to see it described something that defied ordinary language. Not a cloud. Not smoke. Something older than both. A darkness that had its own weight. Its own sound. Its own gravity. The ash fell like gray snow across the lowland towns. On rooftops. On rice paddies. On the hoods of abandoned jeepneys left by families who had fled days before. And this, the scientists watching from their stations knew with cold certainty, was not the main event. This was the opening act. Over the following hours, the eruptions continued in pulses, each one larger than the last. The seismic stations recorded the signals with a kind of grim regularity. Tremor. Explosion, tremor, explosion, a rhythm that had its own terrible logic. Inside the volcano, the process was unfolding exactly as the geological record had always suggested it would. The rising magma, rich with dissolved gases, was meeting the cooler rock of the upper conduit. The pressure was building faster than it could be released. The lava dome that had formed days before was being torn apart from within. Each explosion was the mountain removing another obstacle between its molten interior and the open sky. It was clearing its own path. But then, on the morning of the 12th, something else arrived. Something that the scientists had tracked with growing dread for days. Typhoon Unya, a tropical storm of significant force, moving across the Philippine archipelago on a path that would carry it almost directly over the erupting volcano. The collision of these two forces of nature, one rising from below the earth, one sweeping in from the sea, would transform what was already a disaster into something almost incomprehensible. Typhoon rain mixed with volcanic ash in the atmosphere and fell to the ground not as soft gray powder, but as a heavy, wet, concrete-like slurry. Roofs that might have survived. The dry ash began to collapse. Under the combined weight, structures that had stood for decades buckled and fell, and the darkness, already profound from the ash cloud, became total in some areas. Midday looked like midnight. People moved through the streets of nearby towns holding flashlights, pressing wet cloths to their faces, calling out for family members they could not see. In the evacuation centers, schools, gymnasiums, government buildings filled beyond capacity. Tens of thousands of people sat in the dark and listened to the mountain. They could hear it, even from 30, 40 kilometers away. They could hear it. A low, continuous rumble, punctuated by explosions that rattled windows and stilled every conversation in an instant. Parents held their children closer in those moments. Older men and women who had lived through wars and typhoons and the ordinary devastations of a long life said quietly that they had never heard anything like it, that it did not sound like weather. It sounded like the earth itself was in pain. The scientists monitoring the situation were operating on very little sleep. The data coming in was extraordinary in its scale and its implications. Sulfur dioxide output had reached levels that confirmed the eruption was tapping into a magma reservoir of enormous size, far larger than initial estimates had suggested. The volume of material being ejected was accelerating. And the seismic signals beneath the mountain were beginning to show something new and deeply alarming. The earthquakes were no longer clustered in one area. They were spreading. This could mean only one thing: the structural integrity of the mountain itself, the ancient rock that formed its cone, built up over centuries of smaller eruptions, was beginning to fail. Pinatubo was not just erupting. It was beginning to come apart. That evening, June 12th, the alert radius was extended again. 40 kilometers. Then the order came that many had hoped would never be necessary. All remaining residents within that radius, anyone who had held on, hoping the worst would pass, hoping their home would be spared, were told to leave. Now. Not tomorrow. Not in the morning. Now. Convoys of trucks moved through the ash and darkness. Soldiers and civil defense workers went door to door in towns where some families had stubbornly remained, helping the elderly into vehicles, carrying children who were too frightened to walk. The mountain roared behind them as they drove, and still, the worst had not yet come. The earth had more to say, and it would say it on the 15th of June. A date that no one who lived through it would ever forget. The 15th of June, 1991. It began like the days before it, gray, heavy, the air tasting of sulfur and wet ash. Typhoon Yunya was still moving across the island. The sky had not been truly blue for days. People in the evacuation centers woke early, or did not sleep at all. They listened. And what they heard in the hours before dawn was a mountain that had stopped its rhythmic pulsing and had gone very, very quiet. Those who understood volcanoes knew that this silence was not reassurance. It was the held breath before the scream. At 1:42 in the afternoon. Pinatubo exploded, not erupted, not vented, not released. Exploded. The eruption column that rose from the summit in those first minutes was unlike anything recorded in the modern era. It climbed to a height of 35 kilometers, deep into the stratosphere. In less time than it takes to describe it, the energy released in those hours has been estimated at the equivalent of 10 billion tons of TNT. To put that in perspective, it was thousands of times more powerful than the atomic bomb dropped on Hiroshima. The sound was heard as far away as Vietnam, as far as the island of Borneo, more than 2,000 kilometers to the south. Windows shattered in Manila. The ground shook across the entire island of Luzon. What followed was a phenomenon that volcanologists call a pyroclastic density current. In ordinary language, a pyroclastic flow. There is no gentle way to describe what this is. It is a wave of superheated gas, ash, and fragmented rock, moving at speeds of up to 700 kilometers per hour, with temperatures exceeding 800 degrees Celsius. It does not slow down for valleys. It does not stop for rivers. It follows the contours of the land like a flood, but a flood of fire and gas that incinerates everything. It touches before it can even arrive. On the slopes of Pinatubo, pyroclastic flows poured down every major valley simultaneously. The Maranat, the O'Donnell, the Sacobia, the PASI-G-POTRERO. They traveled for kilometers in minutes. Where forest had stood, there was suddenly nothing. Where villages had been villages empty now. Mercifully, because of the evacuations, there was only a gray, scorched silence. Above the mountain, the eruption column was collapsing. This is the mechanism that generates pyroclastic flows. When the column of material ejected from the volcano becomes too heavy to sustain itself in the air, it falls back to Earth and races outward in all directions. The collapse of Pinatubo's column was catastrophic in its scale. Hundreds of millions of cubic meters of material, ash, pumice, rock, gas, cascading downward and outward. Simultaneously, the landscape around the mountain was being remade in real time. Valleys that had existed for thousands of years were filled in hours with deposits dozens of meters deep. Rivers were buried. Roads disappeared. The entire topography of central Luzon was being rewritten by forces that operated on a geological timescale compressed violently into a single afternoon. In the evacuation centers, the darkness was absolute. Ash had blocked the sun entirely across a vast region. In towns 40, 50, 60 kilometers from the summit, it was as dark at 2 in the afternoon as it would be at midnight. The wet ash and rain continued to fall relentlessly, heavily. Roofs collapsed with sounds like gunshots. People huddled under desks, under tables, under anything that might offer shelter from the weight pressing down from above. Children cried. Old men prayed. And through it all, the mountain continued. Hour after hour. The eruption at its peak lasted for approximately 9 hours of sustained catastrophic intensity. 9 hours during which the Earth reminded everything living on its surface that the stability we build our lives upon is always borrowed. At Clark Air Base, the few remaining personnel who had stayed to protect critical equipment made their final departures in near-zero visibility. The base that had once housed 15,000 people was buried under meters of ash and debris. Aircraft that had not been evacuated were crushed where they stood. Buildings collapsed under the weight of wet volcanic material. The most powerful military installation in Southeast Asia had been rendered in a matter of hours completely uninhabitable. Not by war. By geology. Across the affected region. The human stories were countless. An elderly woman, too frail to be moved quickly, sheltered in a concrete schoolhouse as the roof groaned above her, and held. A father who had refused to leave his farm until the last possible moment, driving his family out through falling ash so thick he could not see the road. Navigating from memory alone. A nurse at an evacuation center, working without electricity, without adequate supplies, without rest caring for they. Sick and the frightened and the lost with nothing but her training and her hands. These are the stories that history does not always record, but they are the ones that matter most. By the evening of the 15th of June, the immediate explosive phase began to subside. The mountain was not finished. It would continue to erupt at lesser intensity for weeks and months to come, but the great paroxysm, the moment of maximum fury, had passed. The cost was staggering. More than 800 people had lost their lives, many of them not from the pyroclastic flows themselves, which the evacuations had largely mitigated, but from roof collapses caused by the weight of wet ash, from lahars, from the cascading consequences of a disaster of this scale. More than 100,000 homes had been damaged or destroyed. Nearly 1 million people had been displaced, and the landscape itself, the rivers, the valleys, the slopes that had been home and livelihood to communities for generations, had been fundamentally, permanently altered. The mountain had spoken. And the world would spend years learning to live with what it had said. When people think of a volcanic disaster, they think of the eruption itself, the column of fire, the falling ash, the dramatic, terrible moment of maximum violence. But volcanologists know a truth that the general public rarely considers. For many communities living near a volcano, the eruption is not the end of the disaster. It is the beginning of a longer one. And in the case of Pinatubo, that longer disaster had a name. Lahar. The word comes from the Javanese language. It means, simply, volcanic mudflow, but the word is far too quiet for what it describes. A lahar is not mud in the way we ordinarily think of mud, something soft, something that clings to boots and washes away with rain. A lahar is a torrent, a fast-moving river of volcanic ash, rock, sand, and water, with the consistency of wet concrete and the force of a freight train that can travel for dozens of kilometers, filling valleys, burying towns, and reshaping entire river systems in a matter of hours. And Pinatubo had produced, in those 9 hours of catastrophic eruption, an almost incomprehensible volume of loose, pyroclastic material, more than 5 cubic kilometers of ash and pumice, deposited across the slopes, the valleys, the riverbeds of central Luzon. It was not inert. It was not stable. It was waiting for rain. In the Philippines, rain is not a rare event. The archipelago sits in one of the most active typhoon corridors on Earth. Every year, without exception, the monsoon season arrives with force and generosity. And in the months following the eruption of June 1991, the rains came as they always did. They fell on the slopes of Pinatubo, slopes now blanketed in meters of loose, unstable ash and pumice. And the lahars began. The first major post-eruption lahars arrived within weeks. They moved down the river systems that drained the mountain. The Pasig Potrero, the Sacobia, the Abacan, the Bucao channels that had once carried clear mountain water to the lowland communities and farms that depended on them. Now those channels carried something else entirely. Walls of gray slurry, 3, 4, 5 meters high in places, moving with a deep, grinding roar that residents described as the sound of thousands of boulders being dragged across stone. Towns that had survived the eruption itself, communities that had evacuated in time, that had returned cautiously after June 15th to assess the damage and begin rebuilding, found themselves facing a new and relentless enemy. Not fire this time. Not ash falling from the sky, but their own rivers, turned against them. The city of San Fernando was among those affected. So was Angeles City. So were dozens of smaller municipalities across Pampanga and Zambales provinces, communities whose names are not famous beyond the Philippines, but whose stories are no less real for that. In some towns, lahars buried the ground floors of buildings entirely. Families returned to find only the rooftops of their homes visible above the gray surface, as if the houses had slowly sunk into a sea of stone. In others, entire barangays, the small neighborhood units that form the fabric of Filipino community life, simply ceased to exist. Not destroyed dramatically, quietly consumed. Covered over, the way time covers everything. But in days rather than centuries, the psychological toll was profound. To survive an eruption, to have made the right decision, to have fled in time, to have protected your family, and then to return and find that survival was only the first chapter of the ordeal, that the disaster had followed you home, that it intended to stay. The lahars of Pinatubo did not last one season. They lasted years. Each monsoon season brought new flows, as the vast reserves of loose material on the mountain slopes were mobilized again and again by rainfall. Year after year, communities that had been trying to rebuild found themselves evacuating again. Roads that had been cleared were buried again. Bridges rebuilt were swept away again. The river systems of central Luzon were transformed on a scale that engineers and hydrologists had never encountered. In the modern era, the Pasig Potrero River, once a modest waterway running through productive agricultural land, had its bed raised by so much deposited material that it now ran above the level of the surrounding towns. Above them, a river suspended over the communities it had once served, held in place only by the dikes and barriers that engineers frantically constructed and reinforced, season after season, in a race that often felt impossible to win. The human geography of the region was permanently altered. Farmland that had fed families for generations was buried under meters of gray sediment. The rich volcanic soil of central Luzon, some of the most fertile agricultural land in Southeast Asia, was gone, replaced by a sterile gray plain that would take decades to recover any productivity. More than 100,000 farmers lost their livelihoods. The economic impact on the region extended for years beyond the eruption itself, in lost harvests, in abandoned properties, in the slow hemorrhage of communities whose young people left for Manila or abroad because there was simply nothing left to stay for. And yet, even in this extended devastation, there were stories of something else. Of communities that refused to disappear, of farmers who returned each year, cleared what they could, planted what the altered land would accept, of engineers and scientists who worked alongside local governments to build early warning systems for lahars, systems that used rain gauges on the mountains slopes to predict flows hours before they arrived, giving communities the time to move to higher ground. Of Ida families who, displaced from their ancient homeland on the slopes, slowly rebuilt a life in resettlement communities, carrying their culture, their knowledge, their identity with them into a new and unfamiliar geography. The mountain had taken an enormous amount, but it had not taken everything. There is a concept in volcanology and in the broader study of natural disasters called resilience. It is not a simple word. It does not mean the absence of suffering or the pretense that loss is acceptable. It means simply the capacity to endure, to adapt, to continue. The people of central Luzon understood resilience not as an abstract concept, but as the daily practice of waking up, looking at what remained and deciding to build something from it. That is its own kind of courage, quieter than heroism, less dramatic than survival, but no less real. There is a moment in the aftermath of every great volcanic eruption when scientists turn their attention upward, not to the mountain. To the sky, because what Pinatubo had done on the 15th of June, 1991 was not merely a local event. It was not even a regional one. In those 9 hours of catastrophic eruption, the volcano had injected an estimated 20 million tons of sulfur dioxide directly into the stratosphere. 20 million tons. And in the stratosphere, that layer of the atmosphere that begins roughly 12 Kilometers above the Earth's surface, above the weather, above the clouds, above almost everything we think of as sky, that sulfur dioxide did not simply disperse and vanish. It transformed in the stratosphere. Sulfur dioxide reacts with water vapor to form tiny droplets of sulfuric acid. Aerosols so fine they are invisible to the naked eye. So light they can remain suspended in the upper atmosphere for years. And suspended they were. Within weeks of the eruption, the aerosol cloud from Pinatubo had spread across the tropics. Within months, it had encircled the entire planet, a thin, invisible veil of volcanic particles. Drifting silently around the Earth at altitudes where no weather system could wash it away, the planet was wearing a new layer. And that layer changed everything it touched. The first effect was visible to the naked eye. If you knew where to look. Sunsets. In the months following the eruption, people around the world noticed that the sunsets had changed. They were deeper, more saturated. Extraordinary purples and crimsons that lingered long after the sun had dropped below the horizon. Artists noticed. Photographers noticed. Ordinary people standing on their porches in countries far from the Philippines noticed, without necessarily knowing why, that the sky had become something different. What they were seeing was the light of the setting sun, scattered and refracted by millions of tiny sulfuric acid droplets drifting in the stratosphere. It was, in its way, beautiful. It was also a symptom of something with profound consequences. Those same aerosols that painted the sunsets were doing something else simultaneously. They were reflecting incoming solar radiation back into space. Sunlight that would ordinarily reach the Earth's surface, warming the land, the oceans. The atmosphere was being partially deflected before it could arrive. The result was measurable, and it was global. In the 2 years following the eruption of Pinatubo, the average surface temperature of the Earth dropped by approximately half a degree Celsius. Half a degree sounds modest. But in the context of global climate systems of extraordinary complexity and sensitivity, half a degree is enormous. It disrupted rainfall patterns across multiple continents. It shortened growing seasons in parts of North America and Europe. It altered the behavior of monsoons in Asia and Africa. It contributed to one of the coolest periods recorded in the late 20th century. A single volcano, on a single island in a single afternoon, had temporarily altered the climate of the entire planet. The scientific community watched this unfold with a mixture of awe and intense professional interest. Pinatubo had provided something that no laboratory could replicate and no computer model could fully substitute. For a real-world experiment in the behavior of the global climate system under the influence of a massive stratospheric aerosol injection, the data gathered in the years following the eruption transformed our understanding of how the Earth regulates its own temperature. It confirmed theoretical models that had previously been difficult to validate. It deepened our knowledge of the relationship between volcanic activity and climate variability across geological time. And it raised questions that scientists are still exploring today. Among those questions, one stands out for its particular gravity. If a volcanic eruption can cool the planet by half a degree, could humans deliberately replicate that effect to counteract global warming? The concept has a name: stratospheric aerosol injection. It is one of the most debated proposals in the field of climate intervention, sometimes called geoengineering. The idea, in its simplest form, is this: if we were to deliberately inject reflective particles into the stratosphere, mimicking what Pinatubo did naturally, we might be able to reduce incoming solar radiation and lower global temperatures. Some scientists argue that in a world facing the accelerating consequences of climate change, such interventions may eventually become necessary. Others warn that deliberately interfering with the global climate system, a system of connections and feedbacks we do not fully understand, carries risks that could far outweigh any benefits. That disrupting rainfall patterns in one region to cool temperatures in another is not a solution, but a different kind of problem that we would be treating a symptom while ignoring the disease. Pinatubo did not resolve this debate, but it gave it a foundation of real data that it did not have Before there was another discovery in the stratospheric aftermath of Pinatubo that concerned scientists deeply. The aerosol cloud did not merely reflect sunlight. It also provided a surface, microscopic, distributed across the entire stratosphere, on which certain chemical reactions could take place. Reactions that accelerated the destruction of stratospheric ozone. In the 2 to 3 years following the eruption, ozone levels over many parts of the world declined. Measurably. This was particularly significant because the ozone layer, that thin shield of molecules in the stratosphere, is the Earth's primary protection against harmful ultraviolet radiation from the sun. Its depletion, even temporarily, had real consequences for ecosystems and human health. And it illustrated with uncomfortable clarity something that Earth scientists had long understood, but that the broader world was still learning to absorb. Everything is connected. The rock beneath our feet, the air we breathe, the temperature of the oceans, the chemistry of the upper atmosphere. A mountain explodes in the Philippines on a June afternoon. And the ozone layer thins over Antarctica, and the harvest fails in the American Midwest, and the monsoon shifts in the Sahel. These are not separate events. They are a single conversation conducted in a language older than any human tongue, between the different systems of a living, dynamic, extraordinarily complex planet. Pinatubo reminded the world that the Earth does not operate in isolated compartments, that what happens in one place, at one moment, ripples outward through systems of connection that span the entire globe and extend across decades. It was a lesson in humility. And in the years that followed, as climate science advanced and the conversations about humanity's own impact on the atmosphere grew more urgent, the eruption of Pinatubo remained a reference point, a natural experiment that had taught the planet something about itself. Whether we had truly learned from it was, as always, a different question. In the years that followed the eruption, the world did something it does not always do after a great disaster. It paid attention, not merely to the immediate suffering, though that attention was necessary and real, but to the deeper question that every volcanic catastrophe forces upon the human community. How do we live alongside forces we cannot control? How do we build lives, cities, civilizations in the shadow of a planet that operates on its own timescale, according to its own logic, indifferent to our plans and our schedules and our need for stability? The eruption of Pinatubo did not answer these questions, but it advanced them profoundly. The story of Pinatubo is, among other things, a story about the success of science. It is worth saying that clearly, because it is not always the story that gets told. The story that gets told, understandably, inevitably focuses on destruction, on the 800 lives lost, on the 100,000 homes destroyed, on the communities buried and displaced and permanently altered. These things are true, and they must be remembered. But there is another truth alongside them. The eruption of Pinatubo was the largest volcanic event of the 20th century. And the death toll, while deeply tragic, was a fraction of what it could have been. By the most careful estimates of volcanologists who have studied comparable eruptions throughout history. An event of Pinatubo's magnitude, striking a populated region without warning and without organized evacuation, could have killed tens of thousands of people, perhaps more. Instead, because of the work of PHYVOLCS and the USGS, because of the seismographs installed in time, the careful analysis of the data, the courage to issue warnings that could not be issued with absolute certainty, more than 20,000 lives were saved. 20,000 people who went home after the mountain went quiet. Who rebuilt, who grew old, who watched their children and grandchildren grow up, because scientists did their work and because governments listened. That success became a model. In the years following 1991, the monitoring of Pinatubo was formalized and expanded. PHYVOLCS has established a permanent observatory dedicated to the volcano, equipped with seismographs, GPS ground deformation sensors, gas monitoring stations, and cameras that watch the summit around the clock. The data gathered there feeds into a continuous assessment of the volcano's status, updated regularly, shared with local governments and civil defense authorities. It is a quiet operation, unglamorous, the daily work of scientists reading Numbers on screens and writing reports that most people will never read, but it is the kind of work that, when it matters, saves lives. The lessons of Pinatubo also traveled far beyond the Philippines. In the international volcanological community, the eruption of 1991 became a case study in crisis management, studied not only for what went right, but for what could be improved. New protocols were developed for the rapid deployment of monitoring equipment to volcanoes showing signs of unrest. New frameworks were created for communicating risk to the public, frameworks designed to convey genuine uncertainty without creating either panic or complacency, because this is one of the most difficult challenges in all of natural hazard science. How do you tell a community that something terrible might happen, that you are not certain, that the earth does not give certainties in a way that they will believe and act upon without losing faith in science when the worst does not come? It is a problem of trust as much as it is a problem of data. And Pinatubo, with its successful evacuation, built on exactly that kind of uncertain but well-founded warning, offered a partial answer. You earn trust by being honest about what you know and what you do not know, by explaining your reasoning, by treating people as capable of understanding complexity. By respecting them enough to tell them the truth. The Eta people, the indigenous communities who had lived on Pinatubo's slopes for centuries, faced a different kind of recovery. Their displacement was not merely physical. It was cultural, spiritual. The mountain was not simply the place where they had lived. It was the center of their cosmology, the home of Apo Namoyari, the supreme being of their tradition, the guardian of the mountain and its forests. To leave was to be separated from something that had no substitute. In the resettlement communities established in the lowlands, the Eta struggled with the particular grief of people who have lost not just their homes but their place in the world. The transition was painful, and for many, it remains incomplete even today. And yet the Eta endured. Community organizations formed to preserve their language, their traditional knowledge, their crafts and rituals. Younger generations born in the resettlement areas grew up learning the stories of the mountain from elders who carried those stories with extraordinary care. The connection to Pinatubo was not severe. It was transformed, carried forward in a different form, in a different place, but alive. There is a concept that appears in the work of anthropologists and disaster researchers, the idea of cultural memory in the face of catastrophic loss. The Eta experience after Pinatubo is one of its most remarkable modern examples. People separated from the physical landscape that formed their identity, and yet maintaining that identity through story, through practice, through the deliberate, loving act of remembering together. It is a reminder that culture is not only a product of place. It is also a form of resistance to displacement, a way of saying you can take our mountain, but you cannot take what the mountain taught us. By the late 1990s, the lahars had begun to diminish, not disappear. They continue to this day in smaller form whenever heavy rains fall on the still unstable slopes, but the worst of the annual flooding was over. The rivers were finding new equilibria. The landscape, so violently redrawn in 1991, was beginning slowly, incompletely to stabilize. On the slopes themselves, something extraordinary was happening. Life was returning. The pyroclastic deposits that had buried the forests, sterile, gray, and hospitable in the immediate aftermath, were beginning to be colonized by pioneer plants. Ferns first, then grasses, then the first small trees, pushing their roots into the cooling volcanic soil. Pinatubo's eruption had, in its destruction, also created something. New land, new soil, rich in minerals, waiting to be claimed by the patient, persistent processes of ecological succession. The forest that would eventually grow on those slopes would not be the same forest that had been there before, but it would be a forest. The earth, as it always does, was beginning again. There is a lake at the summit of Mount Pinatubo now. It was not there before. 1991. The eruption collapsed the upper structure of the volcano, creating a caldera, a vast circular depression in the mountain's crown that, over the years following the eruption, slowly filled with rainwater. Today, That lake is one of the most striking sights in the Philippines. Its water is a deep, almost impossible blue, the color of something that has no name in ordinary language. Ringed by the steep walls of the caldera, by the green of vegetation slowly reclaiming the slopes, by the silence of a place that was, not so long ago, the loudest place on earth. People travel to see it now. They hike for hours through recovering forest to stand at the rim and look down at that blue water and feel, perhaps without being able to articulate it, the particular sensation of standing at the intersection of violence and beauty, of a place that was destroyed and became, in its destruction, something new. The caldera lake is not merely beautiful. It is also watched. Scientists from PhilVolcs monitor its temperature, its chemistry, its water level with careful regularity. Because a caldera lake sitting above a still active volcanic system is not simply a scenic feature. It is a potential hazard. If the volcano were to reawaken, if rising magma were to interact suddenly with that body of cold water, the result could be a phreatic explosion of tremendous violence. Steam-driven, unannounced, potentially catastrophic. It is a reminder that Pinatubo is not a dead volcano. It is a resting one. The PhilVolcs Observatory continues its work. The seismographs continue to listen. The gas sensors continue to measure. The GPS instruments continue to watch for any swelling of the ground. That might indicate magma on the move again. Somewhere beneath that blue lake, beneath those recovering forests, beneath the new soil and the returning birds and the hiking trails and the quiet villages, rebuilding their lives, the earth is still alive, still breathing, still capable. What does Pinatubo mean? 30 years on? It means different things to different people. To the volcanologists who worked those frantic weeks in 1991, it remains the defining event of their professional lives. The eruption that tested everything they knew and confirmed that the work they had chosen, unglamorous, underfunded, often misunderstood, could matter in the most direct and human way possible. Dr. Chris Newhall, reflecting on the experience years later, spoke not of the eruption itself but of the evacuation. Of the 20,000 people who lived because warnings were issued and heeded, he spoke of it quietly, with the particular satisfaction of a person who knows that their work, at a critical moment, was enough. To the Filipino families who lived through it, who evacuated, who sheltered in the dark, who returned to find their homes buried or gone, who rebuilt on altered land and altered circumstances, Pinatubo is a chapter in a family story that will be told for generations. Children who were 5 years old in 1991 are now parents themselves. Some are grandparents. They tell their children about the darkness at noon, about the sound of the mountain, about the weight of wet ash on the roof, and the long drive through the gray towards somewhere safer. They tell these stories not to frighten, but to remember. Because memory is how communities maintain their connection to their own history. Because knowing what your family survived is a form of knowing who you are. To the Edda elders, Pinatubo remains Apo Namalyari's mountain. The eruption was not, in their understanding, simply a geological event. It was an expression of something deeper, a reminder that the natural world is not a backdrop to human life, but its context, its condition, its ultimate authority. This is not a belief that modern science shares, in its literal form, but in its deeper implication that human beings are guests on this planet, not its masters, and that the forces which shaped it operate according to logics far older and more powerful than our own. It speaks a truth that geology itself confirms on every timescale we care to examine. The eruption of Pinatubo also left a legacy in the science of climate. The data gathered in its aftermath on stratospheric aerosols, on global temperature response, on ozone chemistry, continues to inform climate research to this day. As humanity grapples with the accelerating consequences of its own influence on the atmosphere, the natural experiment of Pinatubo remains a reference point. A moment when the Earth demonstrated with brutal clarity both how sensitive the global climate system is to sudden perturbation and how resilient it can be. The stratospheric aerosol cloud dispersed. Temperatures recovered. The ozone layer healed. The Earth absorbed the eruption of Pinatubo and continued. As it has absorbed every eruption in its 4.5 billion year history. As it will absorb, eventually, whatever we do to it. The question that Pinatubo poses in its silence, in the blue of its caldera lake, in the new forest growing over its scars, is not whether the Earth will survive. It always has. The question is whether we will have the wisdom to survive. Alongside it. To live on this planet is to live in relationship with forces that do not acknowledge our presence. Volcanoes do not know we are here. They respond to pressure and heat and the slow convection of a molten interior that has been in motion since before life existed on the surface above it. They are not cruel. They are not indifferent. They simply are. And we, who build our cities and our farms and our relationships and our memories on the thin and borrowed surface of a geologically active world, we are the ones who must do the acknowledging. Who must learn to listen. Who must develop the science to hear what the Earth is saying before it says it at full volume. Pinatubo taught us that this is possible, that with instruments and knowledge and courage and cooperation, with the willingness to warn people honestly and the trust to act on those warnings, we can stand at the edge of catastrophe and bring more people through it than anyone thought possible. That is not a small thing. In a world of growing geological risk, of rising populations living near active volcanoes, of climate systems being pushed toward new instabilities, it may be the most important thing. The mountain rests now. The lake is blue. The forest grows. The birds have returned, and somewhere deep beneath the caldera, in the slow and pressured darkness that no human instrument will ever fully illuminate, the Earth continues its ancient work, patient, powerful, indifferent to our calendars and our fears, waiting, as it has always waited, for its next moment to speak. We would do well to keep listening.